when you have wider pipe, let us say D, instead of 2 inch you make 5 inch. Okay. So initially it was 3 and 8 inch, you make it 5.5 inch. Okay, diameter. So normally this piping diameter, tubing diameter or casing diameter, API will be specifying what will be the diameter. Normally it will be fraction of inch, not in SI unit, centimeter or millimeter. It will be, they will say inch, like 2 and 3/8 inch, 2 and 7/8 inch. These are the designation of the tubing. So normally they will be specifying outer diameter. So in a diameter you have to calculate when you are calculating for fluid flow inside tubing. Now you change piping diameter to 2 to 5 inch, for example. What will happen? Fluid flow rate will go down because same pressure, same flow rate you are maintaining. So velocity will go down. Flow rate will be maintained, but velocity going down. When velocity went down, so what happens? The small sand particle, if there is any sand accumulation, although you have put sand control system, and still some small particle of sand is coming, and because of this low velocity, sand will not move with the fluid. So what will happen? Sand will get accumulated at the bottom nearby perforation zone, because you perforated, right, to get oil and gas inside wellbore. So if you are not maintaining that perforation, that fluid velocity, then sand will get settled slowly. When it is getting settled, after a certain time, you will say everything is getting blocked nearby perforation area. So your fluid is not entering. So then there will be another difficulty. Then what difficulty? Difficulty is that if it is accumulated, then actually you have to remove tubing, or you have to do some workover operation, that is called workover operation. If production is not there, you have to reduce the fluid flow, and if production is not there, you have to stop fluid flow. Again you have to rework the wellbore. Again you have to start production. So in that case, what people will do, normally if sand is coming, take sand out of this wellbore, and on the surface you handle. Then you don't have to work for the in the wellbore. And why workover is expensive? Let's say in some wellbore will be in remote areas. If it is in remote area, what will happen? You cannot access easily, and again you have to go for helicopter transportation. You have to construct. So that is very much expensive process. So you have to avoid workover or intervention of wellbore. So you have to create a wellbore during completion stage. This is problem free. So as the artificial lifting system should work for longer period, longer duration, so that things will be work smoothly. It will be more economical. So if you make wider tubing, so sand particle will be settling, it will be blocking the system, and again rework will be, so it will be expensive process, right? So in that case, what you do, sand is coming, you take to the surface, you handle there. Okay, so you should not take very narrow pipe or very wide pipe. So you should have a optimal pipe. So the completion engineers, when they are installing piping, or in the surface separator system, when a production engineers are setting up pipes, they should create optimal piping size. Yes, they will have difficulty of maybe too much pressure drop or too much sand settlement or some other issues. Permeability, porosity. Whenever talking about reservoir, so reservoir, few terms you have to remember whenever you are studying about oil and gas. The basic term of oil, the basic term used for all oil industry people, like permeability, porosity. What is the permeability? What is porosity? Permeability, porosity. Like first, I draw one picture, one figure like this. Okay, and another figure I am drawing like this. Another section. So let's draw this figure first. And another is there like this. So I have three sections, 1, 2, 3. Okay, so this first part, you can see this is non-permeable. Non-permeable and non-porous. This one is porous but non-permeable. Non-permeable. This is porous and permeable. What is the difference? So whenever talking about porosity, porosity means lots of voids are there. So voids can contain gas, water, oil. So that voids may be connected one void is there, one void is there. If it is not connected, then actually when you are drilling, you cannot get enough production. But if you have void and voids are connected, so here lots of voids you can see, but it is connected. For example, fluid can move like this, right? For example, if I take oil, so oil, gas, water come through this. So these are connected. But if you see second one, this is, the pockets are there, but pockets are not connected. So porosity means you have void, you have oil and gas, but it is not connected. But permeable means voids are there and you are connected also. So whenever, if you have permeable reservoir, then it is very easy for you to get oil and gas. But if you have porous but non-permeable, then you have to make certain mechanism, for example, sometimes hydraulic fracturing or some other job you have to do, so that pores will be connected to each other. Then you can get production. For example, you have oil bore, right? And if you have non-porous, non-permeable, right? So there will be no oil, because there is nothing is there, pore is not there, not connected, so there is no use. Then you have to drill further, maybe you will get maybe porous area, right? Porous area but not connected. So in that case, you do hydraulic fracturing or some other mechanism, or maybe that acid fracturing, and you connect the pores. When you connected the pores, you will get more production. But if you have already permeable and porous, then your life is beautiful. Okay. Okay. So permeability, you should know the definition. What is definition of permeability? Permeability definition is like this: Q equals K A mu L del P. So K is permeability, Q is discharge rate, Q discharge rate, that unit will be volume per time, and K is permeability. Ability. A is area, mu is viscosity, del P is pressure drop, and L is length. So viscosity, normally it will be Cp, area feet square, and pressure drop PSIA, and cross sectional area is A, feet square. Then K equals Q mu L A del P. This is permeability K. Okay, K unit Darcy. So the milli-Darcy they use, Darcy unit, and divided by 1000, so it will be milli-Darcy. Okay, there are different types of reservoir, for the water drive, gas cap drive, or dissolved gas drive. There are many other types may be possible, but basically there is three types of reservoir type. Water drive. So it is like this. So you have one gas cap maybe here, gas, then maybe oil is here, and you have water connection here somewhere, water layer. So water, because of denser, so water will be following the bottom layer, then oil, then gas. Okay. Now when you are drilling a hole, you do not drill up to the gas, you drill up to the oil layer. Okay. So that if water pressure is higher, the water will be pushing the oil up. Okay. So that water is pushing up, so you are getting oil production. So this is called water driven. So this is called water drive reservoir. And next is gas cap drive. Gas cap drive means like same thing. If you have gas and oil is here, you drill here. So gas will be pushing oil down, and because of gas, high pressure is there, so the gas pushing it. So because of that pushing, oil is going up. So this is called gas cap drive. This is water drive. This is gas cap drive. Okay. Next is dissolved gas drive. The similar, you have like like this, okay, and here two phase will be there, dissolved gas will be there. Oil plus dissolved gas is there. So, the dissolved gas will be pushing. So, whenever there will be any small pressure down, so lots of gas will be coming out. Again it will maintain pressure, that pressure will be driving the fluid up to the surface. So, they call dissolved gas drive. So, if you have bottom drive, water can be driven, create pressure from the bottom, or water can be pressurizing from the side. When it is pressurizing from side and it is having different aquifer zone from where water is getting pressure, so that is better sometime because it will maintain pressure continuously. But if the bottom drive, sometimes pressure will be lower, and gas coning may be one issue. Gas coning is like this. So, you are getting what oil and gas production like this, and water coning, not gas coning. So, water will be forming like this, although oil is here. So, water, if you are not maintaining a certain rule of production, so in that case water will be forming on coning, and instead of oil you can get water. So, you have to avoid as if possible. So, when you drill a hole, now drill a hole, you know there is different reservoir types are there. Now, before going for production, actually you have to understand what are the different fluid properties. Properties means how much gas is there, how much oil is there, how much condensate is there, what type of hydrocarbon is there. So, many parameters you have to know before you start producing. For example, artificial lift, if there is one dissolved gas and is getting released during centrifugal pumping operation, that may be a problem. Or on the surface, when you are separating, you do not know what are the Weilbur properties, how to select separator size or number of separators required for your separator system. So, before you go for complete production, you have to understand the fluid properties, Weilbur reservoir fluid properties, and if we take same fluid to the surface, then what will happen? How much gas will be released? What will be the viscosity? How the compressibility? All the parameters you have to know. So, the engineers, reservoir engineers normally during exploration or drilling stage, they will be collecting fluid sample. Okay, and they will create reservoir condition, and that condition then they will try to change pressure, temperature. They will see what are the parameter getting changed because of changing pressure and temperature. So, based on that the completion engineer will decide different completion mechanism or production, surface production of engineers, they will be deciding their surface supporting system operations. So, PVT means pressure, you take certain volume, you change pressure, you change temperature, and you see the parameter. And when you are density measurement, density, and then you do optical analysis, you do volumetric analysis, you check temperature, you check pressure. So, several stages of analysis will be there. Based on that, you produce a data table. So, that table will be used by other engineers and scientists. Okay. So, how they do PVT analysis? Let us say first you take certain amount of fluid and reservoir condition at high pressure and high temperature. Then slowly you release the temperature or pressure. Then you see how this fluid property is getting changed, whether how much pressure, if you are changing temperature, what will be the pressure, if you are changing pressure, what will be the temperature, what is the how much gas is being released, or how much condensate you are getting. So, that all the parameter will be found using PVT analysis. So, when the people who are studying or doing reservoir analysis, they will be getting data from PVT analysis, real field data. From that data, they will do further analysis for finding molecular weight and molecules and so many other stuffs. Okay, fluid properties. So, already you have seen this reservoir is producing fluid, and it is having sand, water, oil, gas, 4 phases actually. So, all the 3 phases are there, but water and oil is actually it will be called as multi-component fluid because both are liquid, but oil industry people, they use 2 phase, although water and oil are same phase, actually liquid phase. Okay. So, normally technical term should be multi-component fluid. So, I will tell that oil industry normally they will be using field unit, and SI unit some companies, for example ONGC using. So if you are interacting with many companies, for example if you have one oil field, so in that case we have to interact with many other companies, services companies, drilling companies, completion company, this company. So in that case you have to know the field unit also. So although you may be working with SI unit, but you have to know the field unit. Okay, so field unit like this, like feet they'll be using, inch they'll be using gallon, barrel they'll be using cubic feet, area will be feet square, pressure will be psi, viscosity will be cp, temperature degree Fahrenheit. So some more will be there. Again I'm not giving the data here, but you please remember the data, how to convert from one unit to another unit. So those data may be required for your enhancing your knowledge. And some other terms will be there. STB, they will be using STB term. STB is stock tank barrel. Stock tank barrel. Stock tank barrel means like you got wellbore fluid, wellhead, choke, separator, then you store in a tank. So that tank will contain no volatile component, and temperature pressure will be standard condition, means 14.7 psi and 60 degrees Fahrenheit or normal atmospheric temperature. So there will be no extra pressure or no extra temperature. So that is called stock tank condition. So many times we specify stock tank barrel, that means dead oil. Dead oil means the oil is not having any volatile component and it is under stock tank condition. Stock tank condition means normal temperature, pressure, you just open vessel, you put it, there will be no volatile component there all around. So that is called stock tank barrel. Okay, now is RB. Sometimes we use the term RB. RB means reservoir barrel. Reservoir barrel means the condition prevailing in the reservoir. The condition, what condition? In reservoir temperature may be 100 degrees centigrade and pressure may be 5000 psi. So that much of pressure if prevailing, that is called reservoir condition. Okay, and if you are taking 1 barrel of oil under reservoir condition, that will be calling as reservoir barrel. Then next is SCF. So before SCF, you have to know SCF. SCF is standard cubic feet. Standard cubic feet, again on surface condition, you are taking certain gas, that is called standard cubic feet. Okay, and is million standard cubic feet. Standard cubic feet. Standard cubic. Okay. Dead oil means the volatile component has gone and you are storing in stock tank. So this is called dead oil. There is no, I mean, if you keep it, it will not give lots of hydrocarbon vapor. Live oil means reservoir condition, you got certain oil. So this is live oil, means it is having all the components of volatile and non-volatile components. So this is called live oil. And SCF, stock tank. Okay. Now this definition sometime will be using randomly when I am teaching artificial mechanism. So you should remember the terms and you should remember the units also, and field unit, you have to be familiar with field unit and you have to be familiar with the specific terms. Phase diagram, this is very common for oil industry people, they will be knowing. So phase diagram is like this. You have T, you have P, this is P, this is T, PT diagram actually, and it should be looking like this. Okay, and one point will be there, it is called critical point. And how to draw it, I will explain. Critical point, and this is called bubble point. Bubble point. Bubble point line, dew point line. Okay, and there will be some other curves like this. 75%, 50%, 25%, and this is called oil, dry gas. Okay, and this is mixed two phase. Mixed two phase means it is having liquid plus gas. Liquid means oil plus gas mixture. And if, let's say, in certain reservoir condition, if temperature pressure is very high, you are in at this point, okay, and you are producing to oil and gas to the surface. So what will happen? So oil surface condition may be temperature pressure, let's say this is 200 degrees centigrade and 10,000 psi pressure, okay, and when you reach to surface, may temperature and pressure will be going down, and if it is here, for example, the surface condition, then still it is dry gas. That means it is gas well. You are not producing any oil actually. But it's certain condition. Let's say if you have oil here, some wellbore is here, and oil, because this is oil zone. This is oil zone. So this is reservoir, and at same temperature you are reducing pressure. Okay. So initially it will reach to this bubble point line. So the liquid will start bubbling actually if you are reducing pressure. Initially pressure was very high, so all the gas, everything was in the liquid form. Now you reduce, you open one valve and reduce pressure. So when you are reducing pressures at a certain time, the same, if you are maintaining pressure, you are maintaining temperature at certain pressure, it will start giving bubble. First bubble came up, so this is called bubble point. Okay, again you reduce further, then it will be creating two phase. So lots of bubbles and liquid will be there in this vessel. Then again if you read further, then it will come to dry gas. So if your surface condition or stock tank condition is here, then actually whatever reservoir fluid was there, that was liquid, but actually it will be gas. Okay. But if your reservoir surface condition is here, for example, then it may be two phase condition. So whenever you are selecting artificial lift or you are completing wellbore with certain artificial lift, so you have to know the fluid behavior, phase behavior of the fluid. For example, it is oil, it is gas well or condensate, or it is producing lots of dry gas or lots of oil. So based on that you have to select artificial lifting mechanism. For example, certain artificial lift may not be able to handle certain amount of gas. So in that case, if you do not know wellbore properties and you are during artificial lift pumping, it is producing lots of gas, your system will fail actually. So you have to understand this one. Then how to draw this phase diagram? The scientists or engineers, they will take a certain amount of reservoir fluid, okay, at a certain pressure, okay, then slowly, let's say you got liquid at very high pressure and temperature, then slowly you release one valve and reduce pressure. Okay, when you are reducing temperature pressure at after certain pressure and temperature, it will start bubbling. You reach to bubble point. Okay, now again you reduce condition, temperature pressure, then after certain time whole system, then only one bubble will be remaining, all will be almost gas. Okay, so that is called dew point. When you are reducing temperature, only maybe some small bubble is remaining and all will become gas. Okay, so that is called dew point. So dew point is definition is there, at which the first droplet of liquid you see when you are reducing temperature. Okay, so that is called so the PVT analysis, those people will do like this. Initially high pressure they will take, they will reduce pressure, they will check what is the bubble point, what is the dew point, and they will measure other parameters also required for your analysis or for your production systems design and production purpose. And the other lines in the diagram, like 75% line, 50% line, 25% line, those lines shows how much liquid is there or how much gas is there. Okay, and if you move from dew point line to bubble point line, dew point to bubble point, what happens? One point will come, where critical point, where bubble point and dew point will be almost matching at certain pressure and temperature. So that is called critical point, PC critical or T critical. Okay. Now if I draw like this, this is actually oil zone and the other part is a gas zone. This is gas, so dry gas zone, that right side, this area. Okay, and the left side area is oil zone or the upper portion. So if you change temperature pressure, the phase will be changing you will get maybe certain condition oil, certain condition mixed fluid like some bubble oil gas, and pure oil, mixture gas. And from reservoir to surface, when you are moving, you have to check whether it is becoming two phase or single phase. If it is becoming single phase, that means it is gas oil actually, there is no liquid actually, it was gas, and after surface also it is gas. But when your phase is changing, then situation will be different. Then handling case, you have to consider many factors before selecting any artificial lift.